Hi, Assalamualaikum. Today we are going to learn about the graph transformation. Meaning to say that we want to transform the graph from one state to another state. So there are three important techniques under graph transformation. The first one is known as the translation, in which we are going to just bring either the graph, for example, suppose we have this is the graph, and then we want to shift the graph to the right, for example, something like this. Or we want to shift the graph upwards, right? So suppose we have something like this, right? So this is actually a process of translation. We shift it to the right or to the left, or upwards or downwards. Then the second one is the concept of the reflection, where we are going to reflect the graph on the x-axis. For example, suppose we have this graph, all right? So we have its reflection over here. And if we have, for example, suppose we have a graph something like this. So if we want to reflect about the y-axis, so it will be something like this, right? Right, so we'll look at later for the reflection. And the third one will be the compression or the stretch, right? So the compression for the stretch, so for example, this is the concept of, suppose we have this graph, and then we want to, for example, stretch, right? So it will be something like this. Or it's compressed, so it will be something like this. And if we have that one, is actually a vertical stretch or vertical compression. But now if we have this graph, suppose we have this, and then if we want to what do we call stretch it, so it will be something like this. This is the horizontal stretch, right? But this is the horizontal compression. All right, now right, so let's look at each of these concepts. Right, so the first one, which is the translation. Suppose if we want to shift the graph to the right, by k unit. So suppose in this case k is actually a positive number, right? So k is a positive number, and then we want to shift the graph. Suppose we have, this is the graph, fx equal to x squared given by this graph. So if we shift the graph by k unit, meaning to say that we have to have the fx minus k. So our graph now will look something like this. So this is our what do we call, this is k, right? Because we shift to the right by k unit. So our function now looks like fx equal to x minus k, right? So sorry, y. Suppose we have this graph, so y minus x minus k square, right? Because we shift the graph to the right by k units. But if we shift the graph by what do we call k unit to the left, all right? So we'll have fx plus k. So in this case, suppose we have something, all right? This is the original graph, right? So fx is equal to x squared, and then we shift it to the left, so we have something like this. So this is actually a negative k, because k is a positive number. We shift to the left side, so we have this fx plus k. All right, so the graph is actually given by x plus k square. All right, so that's the graph here. All right, suppose if it is origin here, right? So this is origin, we assume that is origin there. Okay, now suppose we shift the graph upwards by k units, so we'll have fx plus k. All right, so our original graph, which is fx equal to x squared, so it will be brought upwards, right? Shifted upwards by k units, so it will be something like this, right? All right, so this is k, positive k, right? If the graph is shifted downwards by k units, so we have fx minus k, so we'll have the graph something like this. All right, so this is y equal to x squared plus k, all right? So, and this is y equal to x squared minus k, all right? So this is a negative k here. Okay, so we have four types of translation here. Shifting to the right, so we should x minus k. Shifting to the left should be x plus k. And then we have, shifting upwards, so we have fx plus k, and shifting downwards will be fx minus k, provided that k is actually a positive real numbers. All right, now we go to the second concept, which is the reflection. All right, so if we reflect about y-axis, all right, so to reflect the graph about y-axis, meaning to say that we have something like this, right? So this is reflected by about y-axis, so we have something like this. So this is our final graph. In this case, we have y equal to f of negative f, meaning to say that the variable x inside fx is changed with what we call a negative x, so a negative x plus 1. All right, so that's the graph. But if we have the reflection about the x-axis, so we have this equation y equal to a negative of fx, meaning to say that when we want to have the reflection of this graph about x-axis, will be something like this. So we have this graph. All right, that is the graph, and it is actually y equal to a negative of fx, so fx is actually x plus 1. In this case, this is a negative x minus 1. All right, so this is our negative x minus 1. It is a reflection of x plus 1 about x-axis. All right, okay, so there are two types of reflection only, about y-axis and also about x-axis. So about y-axis, it should be f of negative x, but about x-axis should be y of equal to a negative of fx. All right, now the last concept, which is the compression or stretch. All right, so for the concept of compression or stretch, if we have the y equal to kfx, suppose k is a positive number, but k is actually greater than 1. If k is greater than 1, then we have a vertical stretch, meaning to say that we have something like a vertical stretch, right? All right, so it will go something like this. All right, so this is suppose this is let's say this is y equal to x squared, so this is y equal to 2x squared. What we do is actually we multiply the y coordinates with the value k in this case, right? So in this case, suppose we have 1 1 here, so of course here is 1 2, right? Because we multiply the y-axis, y coordinates. All right, so multiplying y coordinates with the value k here. If the value k is greater than 1 but less than 1, so this is actually a vertical compression, right? Where a vertical compression looks like this. For example, suppose that is actually y equal to x squared. So this graph should be, right, we have the same value here, y equal to half of x squared. So what we do is actually we multiply the y coordinates with value k. In this case, k is actually half. All right, so we multiply by half. All right, so suppose we have 1 1, therefore we have 1 half there. All right, sorry, negative 1 half, right, because it's on the left side, sorry. All right, so that's basically something like this. Now, but if we have something like k inside of together with the variable x here, for example f of kx, if the value of k is greater than 1, therefore we will have a vertical compression. So suppose we have this is y equal to x squared, then if k is greater than 1, then the vertical compression, meaning to say that it will be something like this. Right, so what we do is actually we multiply the x coordinate. Just now for this case, all right, I'm gonna write here, for this case multiply, all right, we will multiply the y ordinate, all right, y ordinate with k, value of k. But in this case now we multiply, all right, the x ordinate with the with 1 over k. All right, so what we do, for example, suppose we have 1 1 here, but now we have half 1. All right, so this is 1 1, but this is half 1, because suppose we have this is actually y equal to x squared, and then the green one will be y equal to half of x squared. So we multiply the x ordinate with the value of 1 over k. Right, sorry, 2x squared, right, 2x squared, right, because it should be 1 over 2 there. All right, okay, if the value of k is actually between 0 and positive 1, right, which is less than 1, so it should be a horizontal stretch. In this case, a horizontal stretch would be something like this. All right, suppose this is actually, all right, if we say this is y equal to x squared, then the green one should be y equal to half of x squared. So what we see is here is a negative 1 1, right? A negative 1 1, but here should be negative 2 1, right? Here it should be negative 2 because we multiply the x ordinate with the 1 over k, in this case 1 over k, all right, 1 over of half, which is 2, all right? We multiply by 2, okay, something like this. All right, never mind. Let's look at some examples to illustrate these three techniques here. All right, there are many methods of sketching the graph, all right, using the three important concepts just now. Suppose we have this graph, all right. So what we should do is we should know what is the basic graph that we should start with, right? For in this case, actually, right, you should do this step by step. You should start by drawing y equal to a modulus of x. So how does the graph for y equal to modulus of x looks like? So it looks like this, right? So this is y-axis, x-axis. Right, so that is the first step. Now, you are going to shift, right? So you are going to shift the graph to the left by 2 units, because if in the second step, suppose I want to sketch a modulus of x plus 2. When we have plus 2 means we have to shift the graph to the left by 2 units. So using the translation, right? We have something like this. So moving to the left by 2 units. In this case, we have the graph being shifted to the left by 2 units. All right. So this is actually, all right. Suppose we have, all right. So something like this. Okay. So yes, something like this. Okay. So this is y equal to modulus of x plus 2, where here is actually a negative 2. All right. In the third step, all right, we can actually reflect. All right. All right. Suppose in the third step we have y equal to a negative modulus of x plus 2. How we should draw this? All right. So this is actually something reflected about the x-axis. Okay. Because we have something like y equal to negative of fx. So using the concept of reflection, so this is actually reflection about x-axis. So if we have this is the graph, right? So this is x and y, and the graph should be something like this. All right, should be something like this. Sorry. All right. So this is this is negative 2, and this is a negative 2, right? Because it is reflected to the x-axis. And finally, we are going to shift this graph, the final graph in the third graph here, upwards by 3 units, so that we have, okay, right, initially we have this graph, but we are going to shift it upwards by 3 units, so we have plus 3. So shifting this graph upwards by 3 units will give us, right, you bring this one upwards by 3 units. All right, so this is x. So of course will be, all right, that one is 0, so of course it goes up until positive 3, right? All right, so x, all right, so this is a positive 3, all right, here is positive 3, but here is a negative 2. Okay, so it goes something like this. All right, sorry. But why does it goes? All right, so of course it goes to 1. Right, it goes to 1. Here it should be 1, because this one shifted upwards by 3 units, right? Negative 2 plus 3 should be 1, right? So it goes something like this. So this is our final graph, right? So you should draw this step by step. It will be given marks for each step. Okay. All right, let's look at the second example. Suppose we have y equal to x to the power of 3, where x is actually greater than or equal to 0, because actually the graph for y equal to x to the power of 3 is something like this, but we only consider the part where x is greater than or equal to 0. We need to consider this function, right? There are many ways of doing this, but one of the ways is, all right, suppose you start by sketching y equal to, right, suppose I'm gonna shift it to the left side first, so I have something like x plus 3 to the power of 3. Yes, all right. So what I do is to shift this graph, right, that is the graph. Okay, I'm going to shift it to the left side by 3 units. So this is x, y. So I have something like, all right, that's it. All right. So of course, when x is 0, y is equal to 3 to the power of 3 is actually at 27, right? It goes to 27, right? Never mind, it will be drawn something like this. Now it's actually shifted to the left by 3 units. So this one should be -3, right? Now, in the second step, I'm going to reflect it on the, right? Because I have, initially I have this graph. Now I want to reflect it about the x-axis, because I'm going to draw the y equal to negative of fx. So this is actually, all right, this is y and this is x. All right, so this is a -3, so it will be something like this. Okay, it goes that way. Yes, it goes that way. Okay, something like this. So this is y equal negative of x plus 3 to the power of 3. But now I'm going to shift it upwards by 2 units because I'm going to add 2 here. All right, so in the third step, I have y equal to a negative x plus 3 to the power of 3 plus 2. Okay, right, so I'm going to bring it. All right, so suppose I have something like this. Right, this is x and this is y. All right, can you imagine that this graph is being shifted upwards by 2 units? All right, so of course, you suppose we have this line here. All right, you just imagine it right now, and it's here is actually a -3. So I start here and then I goes down, something like this. All right, shifted upwards by 2 units. Okay, something like this. Let me draw it. All right, this this looks nice. All right, how do I know about the x-intercept? Right, to get the value of x-intercept, you just need to solve for y equal to 0. Right, and then you can find the value of x. But in this case, you don't have to. Right, this will be something like this. Okay, so this is the final graph. Actually, you don't have to draw this. You can see that here is actually 2 because we already shift upwards by 2 units. All right. Okay, you can actually make a dotted line here to make it clearer. Same goes to this one. You can draw a dotted line here. Yes. All right, now. All right, let's now move to the third example. Suppose we have this question asks us to sketch the graph for y equal to x squared for x between -2 and 2. So, all right, you start by sketching y equal to x squared for x between -2 and 2, meaning to say that that one would be y should be 4, right? Right, so we have something like this. So this is how it looks like. All right, so this is 4. Okay, you know that is 4, and this here is actually 2, and here is actually a -2. All right, so please label your graph with a, what do we call, y-axis and x-axis. Right, so that is the first step. In the second step, it asks us to draw this graph, to sketch this graph. Right, so suppose I start by because I have 2x squared here. Right, now I'm going to shift it to the, what do we call, and show. All right, I'm going to shift, I'm going to make it using the compression, or what do we call, the stretch. So I have something like, all right, I want to draw 2x squared. Right, referring back to this compression or stretch, now we are going to multiply 2 here, all right, 2 in front here, right, 2 of x squared. All right, so 2 k is now greater than 1, so this is actually a vertical stretch. All right, a vertical stretch. So it will be something like this. What we have to do is to multiply the y coordinate with k. K is actually 2 in this case. So in this case, we have y multiplied by 2, y ordinate multiplied by 2. So of course it will be 8. All right, so instead of right, we have the same values, right, for x, in this case -2 and 2. All right, you better draw this way. All right, but the value here is actually 8 now. Okay, right, so this is our y equal to 2x squared. All right, because this is actually a vertical stretch, right? Vertical stretch means that we stretch it this way. All right, something like this. Okay, all right. Now we are going to, you can add 1 at the back there. All right, so what we have in the third step is to have the 2x squared plus 1, meaning to say that you want to shift this graph upwards by 1 unit. So suppose you have that is your graph. All right, so I'm gonna draw. Right, so now instead, all right, so this is -2 and this is 2, so shifting this upwards by 1 unit. So suppose I have a 9 here. All right, so what I have here is, all right, instead of 0, because it is the vertex there, or what do we call the vertex is shifted by 1 unit upwards. So all right, so you're now having a parabola like this. All right, my graph doesn't look nice. Okay, now it's nicer. All right, so I've shifted it upwards by 1 unit. All right, now I'm done with this one, but all right, I have the final one, which is negative, which is I'm going to reflect this the fourth graph I'm going to have. All right, we're going to reflect this graph about x-axis. Right, so where should I draw this? Right, suppose I'm gonna have a new page. Right, I'm gonna bring this as for references. All right, let me copy this one first. All right, paste. All right, so this is the third step just now. So what I want to have in the final one, which is, sorry, in the fourth step, is to reflect the whole graph here by x-axis, about x-axis, meaning to say that I'm gonna have, all right, so this is y-axis and this is x, right? So instead of 1, so I'm reflect it to -1, right? So it goes this way. All right, so it'll be something like this. Yes, all right, and this one is still -2, right? This one is still a -2, and this one, sorry, all right, this one is actually a +2. All right, and this is 9. Right, if you want to draw this. Okay, so we are done with this one. Right, you cannot draw more than 9 because the graph initially have the condition that we can only draw for the range for where x is actually from -2 until 2 only. Right, you cannot draw which is extended, right, from the given what do we call domain. Right, now let me end the show first. All right, now let's go to the fourth example. We have to draw this one, so we should know the basic graph in this case is actually all right, so this first step is to sketch the graph for the radical. Right, the radical graph. So how does this graph look like? So of course this one, the value of x can be greater than 1, so you can start at 0 and it goes this way. Right, that is the graph for y equal to x square root of x. But now I'm going to shift the graph to the left by 1 unit. So I have y equal to square root of x minus 1. Right, so I will have, all right, so instead of starting from 0, so now it can start from -1 because sorry, that one is actually shifted to the right by 1 unit. Right, so you can shift this one to the right by 1 unit. So instead of starting from 0 like this, right, we can start at 1 here. All right, so it will be something like this because I've shifted this graph to the right by 1 unit. Right, in the third step, I'm going to reflect about x-axis first, because I'm going to draw at the negative of square root of x minus 1. So this graph will be reflected about the what we call x-axis. Right, so this is x and this is y. All right, so it starts at 1. All right, So now it's reflected about x-axis will be something like this. So this is our negative of square root of x minus 1. And finally, I'm going to shift upwards by 2 units. So what we have is actually, right, in the fourth step, which is y equal to negative square root of x minus 1. We shift upwards by 2 units. So you just need to shift this graph upwards by 2 units. So we have something like, all right, so this is y and this is x. All right. Let me draw it here, right, x. So this is of course 1, all right, because now it's shifted, all right, so it's here 0 0 origin, so shifted outwards by 2 units. So now you can start as 1 2, all right, so this is 2. All right, so now our green graph will look like this. All right, because it's already shifted outwards by 2 units. All right, you can draw the dotted line there. So this is our final graph for this one, right? We are done with this radical graph. All right, how should I draw this one? You know, okay, something like this. All right, okay. Or to make it clear, right, you just move this one, something like this. Okay, so that looks similar to that. All right, let's look at the fifth example here. All right, so you should know the basic graph should be started with y equal to e to the power of x. All right, y equal to e to the power of x. So how does the exponential graph looks like? So you should know that the exponential graph looks like this. All right, so this is y and this is x, and this is your exponential graph. Right, so this is y equal to e to the power of x. But now your exponents, all right, are now shifted, all right, this one, all right, because it's now shifted to the right by 4 units. So e to the power of x minus 4. This means that we shift this graph to the right by 4 units. So you bring this one 4 units to the right. Okay, something like this. Right. So we have, right, this is y and this is x. Right. Okay. So what will be, okay, suppose you bring to the right by 4 units. So because here suppose we have 4 here, so the value should be 1 because e to the power of 0 should be 1. All right, so it is something like this, right? Something like this, because e to the power of 4 minus 4, e to the power of 0 is 1, so the value here should be 1. All right, 1 4. All right, 4 1 the coordinates. But now finally I'm going to shift this graph, all right, this graph upwards by 1 unit because we have a plus 1 here. So of course in the third step we have e to the power of x minus 4, we plus 1, right? So all right, again, right, this is x and this is y. All right, instead of starting at 0, all right, so we have an asymptote here, right, from this is 1, right, because this graph is shifted upwards by 1 unit. All right, and this is 4 and this should be 2. All right, and we have it, all right, something like this. So it goes this way, all right, that way. All right, so that is your final graph. Right, this graph is shifted upwards by 1 unit, meaning to say that you shift upwards by 1 unit. All right, it will be something like that. So this one looks the same as this. All right, okay. Now we are done. Let's look at the last example here. Suppose we have this one. So what should we do? All right, we should start by drawing the basic graph, which is y equal to the first step. All right, in the first step we have y equal to the modulus of x. So the graph for the modulus of x looks like this. All right, so this is the modulus of x. But now I want to have a positive 2 modulus of x. So what I do, all right, so this is actually a vertical stretch, right? Vertical stretch. Y equal to, all right, so all right, instead of that we have this one. How should I draw this? All right, because we multiply the y ordinate with the value 2, right? Okay, so we have something like this. So this is your 2 modulus of x. But now I'm going to flip it. All right, so I'm going to reflect it about the x-axis. So we're going to reflect this graph about x-axis. So suppose we have this is y and this is x. So of course our graph looks like this. All right, so this is -2 modulus of x. All right, now in the final step, all right, in the 4th step we have y equal to -2 modulus of x plus 1, meaning to say that we shift this graph upwards by 1 unit, so it goes something like this, right? This is y and this is x. Okay, my graph looks like this. All right, so this is our final graph because we have shifted this graph upwards by 1 unit. All right, so that's basically the graph transformation. So we have 3 types of transformation. The first one is translation, the second one is reflection, and the third one will be the compression or the stretch. So good luck at sketching this graph. Be sure that you draw the graph. You know, you can use like 1 page for 1 question, right? Because we have 4 steps. So maybe 1 page of an A4 paper will be enough to sketch this graph. Right? Draw your graph bigger. Right? Put the appropriate, for example, dotted line like this. Right? Label x and y axis and write the equation for each graph. Right? That is important. Okay, that's it. Thank you for watching this video.